Hi everybody, welcome to the workshop. This is the third series. I'm going to talk about introduction to grass. And in this particular term, I am Giuseppe Matulli, working for the Center for Research Computing, School of Forestry and Environmental Studies, and the Library Center for Science and Social Science Information. So today we are going to achieve what we can do with the grass for the analysis of geographical data. You can find the slide over here, so you can directly browsing that web page, and you can start to following up. So GRASS stands for Geographical Resource Analysis Support System, and has been developed already many years ago. Today I'm going to talk about the GRASS feature, how it has been developed and so on. I will concentrate my attention in the GRASS architecture. This is quite something extremely important that are people struggling, so I will spend a lot of time over here. Then we will go to the command structure and the GUI terminal. So this presentation is giving you a general understanding, and then we will use the command line and the graphical user interface to try to understand deeper what I'm going to explain over here in the presentation. So a few words about open source concept. Free software is a matter of liberty. Okay, so has been applied from already many years. This freedom of be able to release a software without any constraints. Okay, constraints in the code, and the code can be really use it and apply to other research, and you can improve it, understand it, redistribute it, and so on. It's under the GNU operating system, okay, foundation. A GNU project has been starting in '84, and now is running in all the different Unix Linux operating system. So these allow you to have a big freedom and a really stable operating system. And GRASS is one of the many projects inside to the open source community. Okay, so GRASS is part of Open Source Geospatial Foundation. That is a foundation that is including all the open source software and try to coordinate the activity between all of them. And also, especially in the teaching procedure, there is this Geo4All. That is something quite important that are helping in spreading the news and spreading the teaching activity for the different open source software. And of course is very well linked with other kind of open source software in geographic space like GDAL, PostGIS, Quantum GIS, Map Server, Open Layers. Especially this one has been covered in previous workshop, but Quantum GIS we will briefly see today, and Open Server, Open Layer are for the web GIS interface. So the capability of GRASS to communicate with all this software allow you to expanding the analysis even beyond the point where GRASS cannot do it. So in this context, it was a United States software starting in '84, actually developed since '84. Then it was completely abandoned for like 15 years, and then in beginning of 2000, a group of developers getting back and has been developed in the last 18 years in a very powerful way. And now there are 350 modules that you can do visualization, working with raster, vectorization, and again is linked with the different software, and especially for a statistical point of view is very useful because it's linked with R. Okay, so these are an advantage that can push the calculation not from a geographical aspect but even from a statistical aspect. So how it works usually, this scheme is really just a matter of is valid for many software where you have a bunch of users, and some of them are developers that are working for the creation of the open source, and they keep receiving feedback through internet from the different mailing list, people that define bug, or documentation, producing sampling data, and so on. So all these framework is completely active, and you can receive a lot of information among all these ones. Don't think that open source is a synonym of something old. Actually, it's extremely update on the current science situation, okay? Because the developers are really connected with the demand of the user, and the user are asking through mailing list, I need this stuff, who can help me? Who can develop this? And they reply. And so it's very flexible and dynamic in this sense. If the developers use something, is developing something that nobody is using because there is no interest, after one or 2 years, he will just go down, you know, will not develop even anymore. Rather, if he's keeping, the community is keeping asking and helping, because then arriving older developers, then is the open source software is going up and up. So in this context, what GRASS can do? So you can work mainly in raster operation for massive data process, and in vector, also in vector operation. For my computation, I use more the raster operation. We will see several applications of raster, mainly because all the satellite are raster image, so I always use data from satellite that are directly under raster environment. And also because the computer is much efficient in working with raster, because it's just a matrix, okay? It's a regular matrix where the computer can really go fast line by line and process. Rather, the vector is a completely not regular file, and the computer takes longer in process this kind of information. Then you can do different kind of vector analysis and visualization in 2 and 3D. I mainly use 2D mapping, but there are also work in 3D mapping, in 3D maps and volume. Is portable in all the different operating systems, so you can also install it under Mac and under Windows. With Mac is working a bit better, because Mac is nothing else than a fancy Linux on the back end. And with the micro Windows is still working, but you will not have the full flexibility and the language interpretability that you have under Mac and under Linux. He has a modular architecture and scripting capability, okay? So we will focus in this scripting capability for batch processing. So these are advantage for massive data analysis, because you can build up your scripting procedure and let the work run, for example, in a node, and using the different CPU from a big computer cluster. So now the architecture. So please here, maximum attention. Okay, so this up to now was a story. Now we're really understanding how the software of architecture is built up. So each one of these boxes is nothing else than a folder, okay? So imagine that you have a bunch of these folders in your computer. And this is the architecture that GRASS build up in automatically. Okay, so you have always a GRASS database that is a completely empty folder in the beginning. So in our case, the GRASS database is called OST for SAM, and then the name of the folder for the GRASS database is GRASS database. I always use the same name, okay? Then under the GRASS database, you have your location, and you have, for example, this location is called Europe. Under Europe, you have the map set that can be, there is always a permanent, and then can be a V-model or a PSAM, and these are user-defined. It's something that you create. So again, try to remember always these stairs: GRASS database, location, map set. And every time that you have to start a GRASS location, a GRASS session, you have to say to the computer, I want to enter in GRASS database Europe permanent, or GRASS database Europe V model. So you have to give the step where to go in, okay? So, so this is quite completely different from other software, from Esri, from QGIS, that you can enter wherever you want. You can have your TIFF file in the desktop, or you can have the TIFF file in another folder, and you can still open it without problem. GRASS, no. This structure is very rigid, okay? And of course, you cannot keep in moving folder as you want. So if you take this one and you bring it outside, it's not going to work, okay? Again, because the software need always these 3 steps: GRASS database, Europe, and then the map set. So keep in mind always, and I will keep working on this concept during the workshop. Any question? Yes, please.
When you have a new project, do you need to build a new database?
Perfect, perfect. So when you have a completely new project, you have to build up this structure, okay? So we will see how to do it. So first we will see and enter and using something that already exists, okay? And we will understand this concept, and then we will use it, a new completely new file, to build up a new GRASS database location map set, okay? But keep in mind these steps. So the difference between between these 3 folders. So the GIS database, we say that is just a completely empty directory in the beginning that is holding the different location and map set, okay? The location are defined by coordinate system map projection, okay? So you can have a location for each single map projection that you are using. So these allow you to have different file under different projection in each one of the different location. So you can working, for example, in United States under NAD, and in Europe under LA, another projection, okay? So this is quite rigid, and also GRASS will complain if you try to take one file from one project and bring it to the other one. You say, no, you can't. The location is completely different, okay? And then the map set is like your project. You can have different projects that are still working, for example, under the same location, under the same projection system, but then you can have, for example, a model for your soil mapping, another model for your vegetation mapping, and so on. So this one is giving to you flexibility in building up your own project. And again, in the map set, there is always one map set that is the default one, that is the so-called permanent. So again, this one, GIS database location map set, this is a default one, has been, and we can see why is the default one, and then you can keep adding the different one in according to your user request. So the architecture is not over here, it's going even deeper, okay? So here you can see perfectly the same GRASS database map location map set, but in a bigger environment, like if you have more location. So for example, you can have more location, world, Asia, and Spain, Europe. Then inside Europe you have the different map set, okay? So if you get inside one map set, then there are other different folders, okay? So the most important part is up to here, to the left. You don't need to remember all this one on the right, but it's good to know why is built up in this way. So for example, inside to the permanent, you can have the vector data, or you can have the raster map. So be careful. Inside to the raster map, you have 2 different folders. Okay, so when you're importing a TIFF, for example, the TIFF doesn't go in one of them. It's going everywhere. It's going to be splitted in different files in the different folder. So for example, this folder we will have the value of the pixel, really the matrix. This one will have the header, the information about the projection, how many col, a row. This one we will have information about color, if he has it. This one will have information, is a floating type. And this one will be information about the histogram, the statistic, okay? So that's why you can't take a TIFF and dragging, copy-paste everywhere. So you have to use a special rule, a special condition command to import the TIFF inside to this structure, okay? And this is the more scary one, and the people that just abandon this idea of, but if you keep in mind this process, this GRASS database, location and map set, you can building up your procedure without problem, okay? Any question? Maybe now it's a bit fuzzy, but for me it's important that you have in mind these three steps: GRASS database, location, and map set. And every time you have to specify the stairs. If you are missing one, then he's going to complain, the software. He's going to say, no, location is not that one. The map set is not defined, and so on, okay? For giving a bit of you an idea, is like you start your R section, and you want to set up the working directory, okay? You say, okay, my working directory is going to be here. It's pretty the same, but in this case, you have to have 3 steps inside to the working directory, okay? So, yes, this one is what I described before for each single raster, for inside to the raster cell. And there is always something very important over here that I like to comment from now. So one of the folder is including the so-called wind. Is nothing else that a file with the coordinates of your working region. So be careful about this concept, because it's extremely important and extremely efficient in GRASS, and there is no software. There was in the old ArcInfo, and then they just don't use it anymore. So the concept of the region of map set, the region inside to the map set, is this one. So consider that I have a TIFF that is big like this big screen. But then I want to work just in this region where is white, okay? I'm not going to cropping anything, but my computation is going to set up only and coming out only for this region. So of course you can already thinking that if I process the full TIFF is going to be long, but if I process only this one, it's going to be extremely fast because it's very small. So in the mind of the scripting procedure, you can test your script in this little study area, and then before to run it, you just enlarge the study area to the full computation. And again, this is stored in a file that gives you the coordinates of these very simple 4 lines, okay, with the coordinates of this point. And we will see how to work with this setting region and what you can change, okay?
Does it
yes.
Just mask all the
Perfect. It's going to, your output is going to be only here. Just does not consider. But doesn't mean that your input are going to be cropped. It's going to be cropped only the output. So your input, they are completely untouched.
Does it
okay?
retain the value of the other area, or do you have to rerun the computation?
No, in case you want this part, you have to rerun the computation.
Oh, okay.
That's why. So you tested everything under a small region, and then when you are assured that you don't have syntax error, that your output are what you want, then you say, okay, let's leave it run for another 2 hours with the full computation, okay? So, and this is quite appealing because you can keep working in a fast mode, but and retrieve the result very fast, and then when you are ready for the computation, you just leave it run for the full night, and the day after you have the full code. So, GRASS command. They are really, you can identify immediately And this is quite unique because the grass command, they start all with one letter and then you have the dot. So as soon you see one letter plus a dot and with following something else, means that you are inside you are following up with the code. So for the grass code. So for example, the G stands for general data management. So you can think about, for example, renaming a raster, copy, setting up the G region. So everything that is general. Rather, D is for the display, is not use it anymore because there is a graphical user interface, so we are not going to use it, the dot D. R, the raster with the modules, is the one that you are going to use more, and you can think about R map calc, R univariate, R principal component, R dot, whatever you want, buffering. Vector for vector processing, so V buffer, V cleaning, V intersect, and so on. Imagery for satellite image, so for example, principal component analysis for satellite image. And these one are for 3D raster process. I didn't use so much, but they are coming really, they are doing a lot of work and developing a lot of modules in this context. This one also, the database is linked with the vector, so they are going together because you have the attribute table in a vector are stored inside to the database. And this database can be linked with PostGIS, okay? So if you really need a lot of working with the command. And this one, PS, is for map generation, okay? When you have to create a lot of map and so on. But also this one maybe is a bit not very used so much now. So let's go let's see how is built up a command. So has been born under Linux, Grass, so of course is going to be following the typical pattern of a bash language. So a bash language is nothing else that the language that is maintained that is running in the terminal. So whenever you open your Mac or you open the Linux terminal, what you write in the Linux terminal is a bash language. And for this concept, the syntax, maybe I'm already, yes. So the syntax is always this one. You have a command, you have several flags that are always between square brackets. So whatever is between square brackets means that is optional. Rather, a parameter and other flags. So in few words, you see this one. So if you want to, for example, you want to create a buffer around a road network, a typical GIS operation. So the command is going to be rbuffer. You will have your input name, like your road. You are going to have the output name, the distance, every 1, 2, 3 kilometers, and the unit. So as you can see, everything that you put over here is going to be optional. So if you want to build up in one line the input parameter, input roads, output roads buffer, distance every 100, 200, and then you give unit kilometer, and the option override to override your raster. So this is, as you can see, is the same syntax over here for the bash language, okay? All these one are the parameter over here, and whatever it was optional, it was between square brackets. Okay, can you see if you have already experience in a bit of bash or with the R, you can translate the syntax for our concept, let's say. Okay, and all of them, they work in the same way. If you have another command, mapcalc or raster neighborhood for filtering and so on, so you just go there and check it, which are all the So you can find all the different GIS operations that you have in all the software are also over there in Rust in GRASS. Okay. Any question in this aspect? Okay. So we go for the graphical user. You also have a graphical user interface that you have the native one for GRASS, and we are going to use this one. But there is also an interface with the QGIS, so you can use QGIS to open raster file. Usually, I open this one for some visualization, and we will see how to use it also for building up location map set, and also how to use the command and how to build up your scripting procedure. Okay. So, and of course, you are going to have the command line that we are going to use it in the terminal with a welcome message for GRASS, and you are going to, it's possible we are going to use it under Bash environment, but you can use it also under Python. So you can import the GRASS Python modules, and you can keep working with GRASS under Python. Now there is a tendency to work more under Python, but actually the syntax is a bit more complex because you have to put a lot of quotation and so on. So I keep working in the Bash. It's faster for me. But feel free to shift and change when you get the concept in mind. So now from a practical, how we are going to use it and how you are going to start it. So my always advice is downloading a virtual machine from OSGeo Live. Probably all of you already have it, and then following some exercise that already they are built up. The OSGeo Live is a Linux virtual machine that has been built up from different developers. You can go in this internet site and just download it, and you have the advantage that all the software for GIS are already installed over there. So there are all the GDAL, there are all the different geospatial browser, desktop, navigation maps, spatial tools, web service, and so on. So everything is already built. Over here you have the installation procedure to use it as a virtual machine, but also to install the OSGeo directly in your operating system. So this is something that I suggest if you're starting from scratch, rather than going to use Ubuntu and then install all the software that is can be a bit complex in the beginning. This one is already pre-cooked and ready to go. And you can have also some sample data that you can start to use it for get familiar. So in this context, we are going to use these two web pages for following up the workshop. So the first one is going to be an exercise in entering in a GRASS location, a map set that already exists in the virtual machine. And this second one is going to be to create a location starting from completely from scratch. So when you are you have a database, a file, a TIFF, that you are going to use it to build up your location and map set. Okay? Ready? Or question for this? I think the question will come out during the exercise. Okay? So let's starting the virtual machine. Probably you have already going on. If you have, is going to be lock. The password for the virtual machine is user. Sometimes you have to type twice, like now. No, like now. Yes. Okay. So over here you have all the different software, as we mentioned, that you can access from here, from the control panel over here. And in particular, we are going to use our terminal. So click on the terminal, and we are going to open we are going to open the web page. So as you can see, also in my case, I'm opening the web page that I'm going to follow inside the Firefox of the virtual machine. Try not to use the Firefox or another browser from your Mac or PC, because if not, the copy-paste is quite complex, okay? So then if you click over here on the left, you can arrive to the spatial ecology exercise, okay? And then if you go down to grass, we can click over here in the grass 7.2, okay? So there are also other exercises over here, a bit more complex, so you can use it afterwards, but this is really the starting point, how to start, and then you can go deep in some other building up a procedure. So we are going to use this one as a first one, and then the second one is going to be this one. So you can click in this one, and we are going to follow step by step this web page. So you can copy paste, because the commands are not going to be so many. Now I'm going to zoom in a bit more. Yes, and now it's going to be quite straightforward. So I will try to work in this way, that I have always the command visible and the terminal ready to work and to enter and to show to you, okay? So whenever you want to start grass, there are, we can see starting as a command line or starting as a graphical user interface. Okay, so let's start it first as a graphical user interface. So if you type grass 72, the Vuix Python, that is the graphical user interface. Okay, you have to specify. Yeah, he's already complaining. This is the first complaint. /user is not a valid grass location. That's why you have to really specify very well where you are going to start it, okay? So let's go to the second one, to the second line, and I can say now, okay, start grass. Here we can put the command of first before Vuix Python, okay? And we are going to say start grass 72 using this grass database, enter in this location, and using this map set. Have you seen the stairs? First, second, third. And we already mentioned where to start. So as soon as you enter, you are going to have the welcome message that we will see now, and the graphical user interface that are going to pop up. You are going to have two graphical user interface, two windows, one for the display and one for the command. We will see now. So over here, if you are in this situation of standby in the terminal, just pressing enter. So this is the graphical situation, the typical situation, welcome message of grass. So you have how to access to the manual, the different version, and how to start in the graphical user interface. Okay, so in our context, I mentioned to you that when we are inside grass was built up under a Bash system, environmental framework, okay? So over here you will have the advantage is that when you are here, you have all the Bash command and all the grass command ready for you. So for example, how I can list file in a Bash. For you, how I can list file, command, Brian, ls, okay? I list a file. So this is a Bash command, but I can run under grass. Okay? So over here, ls is giving to me the information about what is under my home. Now I will go deep in this concept. Okay, so over here we have the graphical user interface that is built up in this way. You have, for example, over here you can go quite, when you go here you can see, look, add raster map layer. You just click over here, you select, and you select one map raster layer, for example in permanent. Look, you can already see that under your location you can see permanent, PSM and PStat. So you can see maps under different map set, okay? Okay, and then you do okay, and it's going to appear on your right side the map. So this is the display, and this is always the stuff. So everybody has the two windows open. Can you follow? Perfect.
Where did you open the?
Over here, this raster one. And you can learn it by yourself. If you just keep moving, you can see also all the information over here. And over here, you can start to see all the different commands that GRASS has. And one of the advantages of the graphical user interface, this is telling neighborhood analysis moving window, is telling already the command that is running. Okay, so with the graphical user interface, you can start to learn it, the command line. And even better, for example, if we go, let's open this one. Anyone, you can open anyone. As soon you start clicking the, and you start to put the different option and flag, check out over here. You have the line of your command line that is building. Then if you do copy, you copy this line, and you can put in the scripting procedure. So if you don't know the syntax, go in the graphical user interface, select what you want to do it, click the different option, read the manual, like always, read the manuals here, help, that is very detailed. Read the manuals, see, I want to do this, I want to do that one, and you start to click, and you will have your command line already built up, okay? For all the different commands, anyone is going to be working perfect the same. So this is the aspect of how using the graphical user interface to learn the GRASS syntax, okay? Perfect. So concerning the command, if you want to have a list of the command, you can use these tricks. You can put, for example, r dot, because I want to see all the commands that are coming out on the raster environment, okay? Then if you press tab twice, it's going to list, and you say yes, it's going to list all the different commands that you want to use it, okay? And then you pick up, oh, okay, I want to do quantile. Let me see if I can do quantile in a raster map. Okay, r dot quantile, I don't know if I use it. I don't know how to use it, help, and I can get the help of the quantile, of the command rquantile. This is a really short help, but of course after a while you can identify very fast which are the different flag, and if you need more information you go online and you see the full help, okay? And from here you can start to build up your command, yeah, my quantile, okay, my input parameter equal to, and you put your map, and then output, bins value, and so on. So you build up your command as you wish, yeah. And we will see how to use it. Yes, actually, to have a long, yes, with the man in front, you can have also the long help that tell you nothing else that is perfectly the same the one that is on the web. Sometimes I go to the web, but sometimes I'm already in the terminal, so I just do man and the command that I'm seeing here, and I can see very fast the different command, yeah. Okay, so this is how you access the capability of grass and how you start learning the different option of the command. So there is this command g.gesenvironment is nothing else that like when you print the directory. So you want to see where are you under grass, okay? So in this case, again, we are under my GIS database, grass database, my location Europe, and my map set permanent. So when you don't know where are you, g.gesenvironment, and you get the list. Okay, so now everybody please pay attention over here. If I do print working directory, pwd, look where I am. I am /home user. So I am here. This is the tilde of the home user. I can change. Be careful. I can do cd ost for SAM. So now I am asking where I am in grass. Where I am.
OST for us.
Okay, let's see. I'm perfect in the same place. Okay, so be careful. This up to here is the location for grass. I'm under Europe, map set, permanent. Over here, I am in the folder where the bash command can be release output, where they are going to be save output. There are two directory. One is the grass directory up to here, and this is the bash directory. So what does it mean? That everything that has an output from grass, a raster or a vector from grass, is going to be splitted inside to these stairs. Okay? Rather, if you create something under bash, it's going to be in the OST for SAM. Perfect? So over here, if I do ls, it's going to print what? It's going to print my command, my folder that are under my OST for SAM. And I can see, if you want a graphical representation, we can see over here, /OST for SAM. Perfect. The same folder that I see over here, I see over here in the terminal. So far, so clear, no? Rather, if I do something with grass command, it's going to be splitted inside to these stairs. Okay? So, just to give you, you have already see an interface, I mean a connection between grass and bash. I'm working with the two command, with the two software in the same way under the same environment. At this point, if you do R, you can enter from grass inside R. And so what you are going to bring all the location and map set inside R already, and you can access the raster file. So this is the language communication that you cannot achieve it in under another operating system, or if you are, they are not so flexible. Okay, so this is where you can, and of course over here you can communicate and see and import variable and do whatever you wanted. Okay, so this is just to give a feeling of the flexibility. I'm not expecting that you mastering already this kind of connection. So now it's important that you have location for grass and location for bash. Yes, please.
So does the R work in the same directory as in bash?
Yeah, in that case, yes. In that case, is your, yes, in that case, your working directory of R is going to be OST for SAM, but you will be able to access to the raster file of grass. Okay? So we will, this is really language integration that can come after a bit of experience, because you have to be good in bash, in grass, and in R. So and then you can start to communicate between all of them. Okay? print working directory. So usually what I do it, I always enter in the GRASS database. So usually I do like this. I enter in GRASS and then I migrate inside to the GRASS database. So inside here, you have your location. Okay? Over here, you can keep doing stuff. You can create files. Under your Europe, you can see that you are already in the GRASS place, you know, in the GRASS location. So I will never mess up in this folder. I will not create additional file, other folder. If you want to create something that you are saving or like an output for some bash computation, go in the GRASS database. Go one level up. Don't mess up with under that line, okay? So here I can create a file, echo, I don't know, this file, test.txt. ls. So now I will have my location and my txt for something, okay? So just create a file. You can create a file under a GRASS database, but don't create one level down, okay? And neither in the map set. Of course, you can have the power of bash, so you can even completely remove Europe, your location, in one shot. But of course, then you cannot enter anymore in GRASS, okay? Because you're breaking all this structure. So be careful also to, if you are in GRASS database, be careful if you have to remove something because you are going to damage your full location and map set. Clear? So in my case, I can remove my test and now it's gone. Okay. So now we keep see all these aspect of the GRASS. Now that we saw the aspect of GRASS database, location, and map set, there was this concept of the G region that we need to understand. So G map set minus L is given to me. Sorry, the map set is giving to me the list of map set that are there, okay? So now I was in permanent, and be careful about this one. So the concept of map set was mainly for protecting your data. So when you are in one map set, you can create only in that map set. You can read from all the map set, but you can create only in the map set that you are in. So try to imagine why one is called permanent. What do you save in this permanent folder? Your input file that are to be, you don't want to mess up with your input file, you know? So in the permanent are the input file, and in the PSEM, in the other map set, you can have the output of the reading. Due to that, you can read from everywhere, but you can produce only where you are. From there, you can have the output. In this way, you don't make a mistake and delete your input, because you can only write where are you. So if you are inside to PSEM, you cannot remove it what is here. You cannot overwrite. You have to change the map set and go in there and do. So this is the shifting that we are going to check. So for example, we were in permanent, okay? G.gis environment, try to do it. We were in permanent. Now I want to change map set. And I do gmap set PSEM. It tell you with a little warning. Okay, so now you are, look, now you are in PSEM. So how I can see, if I do again gis.environment, I can see now that I am in PSEM over here. So I shift between map set. Okay? So each map set has his own G region. So what does it mean? That in the permanent you can have a very huge TIFF, and then in the map set you can have map set for this region, a map set for this other region, a map set for this other region. Okay, your input file is going to be one, but your map set and your output are going to be for this region, and that region. So these allow you flexibility, because you are not cropping every time the file, but you are using the wide file for producing something small. For example, this concept in R, there is not. So if you have a raster file, you have to crop it first, and then from that one you have to keep going with the cropped one. Over here, no, you're just setting the region in a small area, and then from there you keep working in that aspect. Okay? So now that we see how to shift between map set, I want to see what there is inside this map set. I want to see the raster file. So you do G list rast, and you can see, actually, if you put minus P, is a bit more well built up. So check. I am in PSAM, but I can also read permanent. Read, not write. Everything that I write is going to be in PSAM. But I can also see my input in permanent. I cannot see VSAM, the other one. So you can also allow to see the file from that one. So this is going to be in readable, and here is going to be in readable and writing. So now if you change again, and you do, the other one was called, PSAM stat. Now I enter in PSAM stat and I redo the list. Look, now I can see everything in PSAM stat and permanent. I cannot see anymore the other one. Okay, so this allow you to protect your data and to not mess up. And of course, you can have the same name of raster inside here and inside here, but because they are disconnected between them. I always suggest not to do it, if not you get confused. If you want to exit, you just press Q. Perfect the same for vector. Okay, with glist vect, you can see the vector that are inside here. So again, the two important commands when you enter gis environment tell you where are you, and glist rast or vector tell you what is inside there. Okay, these are the raster, and again these are split inside all this folder. You don't see them. You see as a unique file, but you can see. In particular, if you want to go one level deep and understanding which kind of file I have, it was raster, you can just take it one, keep it one, any one you can copy, and then you do R info, even if it's not the same, no problem. So what do you get now? R info is like, it was like GDAL info, perfect the same. It's giving to you the information about the raster. So in this case, you have a raster with 441, 740 lines with this extension, minimum, maximum. Okay? So we mentioned before that you have the capability of bash combined with the one with the R. So with the one with grass. So what does it mean? So means that, for example, you are printing this information with with grass, but you are interested not in everything, but only in this line. So this one, every time that you print something, is a terminal output, okay? So it's a text that you can manipulate with bash command. So in this case, for example, I want to just get information, so grep this line that contain minimum and maximum, so range. So if you want to have just this line, you can just adding a bash option and you can get just that one. If you want only the last number because you are interested in the max, you can, using another command, awk command, that you can say print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. $10 is going to be my last column, my command number 20, okay? And of course, this one then can become a variable that you can import in R, for example. Can be a text file that you want to import in R. So over here, you start to see the efficiency of you are doing something in grass, but you are retrieving by combining bash command, retrieving a number, then you can bring inside to another. And over here, you can see the flow. You can build up the typical flow that everybody is talking about, but I don't know how many people are building up this flow chart when they say, okay? So this is the connection that you can build and do it. Okay, appealing. So if you want to adding information, if you see that in glist, for example, you want to see also the other g.list, Rust. So in this case, you will see only information for one map set. But if you do it this one, g map set, and you put the other one, so be careful if you are in one, you have to put the other one, PSM, because I was changing a few times. Now, if I list it again, now I can see everything. Do you see? Now I can see. Before I could see these two, now I can see everything. And of course, I can also read this file. So this is like you open the door and you leave it open, okay? But you're still in the same one. You are still in the, again, if you don't know, G's environment, okay? Okay, so I would say spend maybe 3-4 minutes to do this kind of operation. Migrate, check where are you, and you say, okay, I want to enter in this map set, and then get a file and get the information of this file with our info. Okay, so again, this environment, G1, and again, you just check the command that we did. You get this one and say, okay, let me enter here. You enter in one, you list it, you pick up a file, and you see the information of this file. Can you change, migrate? Can you change from one to the other one? Okay. Okay. Any question? Can you do it or not? Tell me. Can you get an info or our info? Could you change the location, map set? Okay, map set, no, okay, map set. Okay, cool. So now let's see, when I mentioned to you that we can read file from another location, do something, let's see, this is the concept. We have to change a bit this line because vModel is a map set that is not anymore there. So let's build it up together. You just list one. So you are in your, I am in psem stat, for example. So I want to read something that is in another directory, in another map set. So I can list glist rust, okay, always with minus p. So just pick up another one, for example this one, psem realized, in my case. You can copy this file, and then you can see, okay, let me copy in my directory, in my permanent. So you can see gcopy raster from psem, and you say at psem from, and then you give the 2. It's going to be my psem realized 2. The copy is always from to. I want to copy this file that is located in this other map set and bring it here with another name. Now if you copy, it's going to say copy raster map set that was in psem and copy where in psem 2 that is your current map set. So now if you list it, now you have the 2 over here, okay? The file is super protected because you cannot remove it, that one, but you can copy there and do something else. And now at this point, for example, you can remove that file. You can remove that file. So g remove -f, type rust, and you remove the one that you copied. So now you are removing the file and it's fine. You can remove it. This is to show you that even if files are in another map set, you can still access by giving at the location where they are, at psem. And of course, you can also copy stuff that are in the permanent. Perfect the same. But usually in the permanent you have your input data. So you just, maybe you want to just copy the input data, try to do something, and then see if it's working or not. Okay, please.
So when you remove you don't have to specify where it is.
Where it is also, because even if you try to remove, let me try. If you try to remove the one in psem, okay, you can't, because you have to enter in that map set and then you can remove it. So every action that produces an output an action that is a strong action, you can ask the list, the rinfo of a file, that is another one, but you cannot remove it r.info of this file. You can do it because you are not just getting an info, but you cannot create something. You cannot do an output, and of course remove it is not possible. So this allows you to have your file extremely protected, and you can keep working that permanent file, that permanent as you go on with analysis. Okay. So the g-remove we mentioned. Okay. So now we are in this G region. So we mentioned about the G region a few times in the presentation and also in the example, but now let's see in practical what they are, this G region, okay? So if you do G region minus P, you can see that your corner of this region, okay? So by the graphical user interface, if you still open, you can also changing this G region. So over here, if you do, and this is helping you, so if you do, try to do it with any map that you have, is fine. If you do over here, setting region, and you do display region, so setting region, display region. Over here is going to print the region that you are, okay? So over here you say, okay, I have this map, I want to focus just in this area, I want to set in my G region over there. So you can go to raster. No, actually it was not in raster, it was over here. So you can do over here, you can zoom and you can say set computational region, extend from display, or extend interactively. So now you zoom in one area, as soon you release, your region is set, and if you print back again, this one, now you can see that the region has been changed. So before you were, look, 400 rows, now you have 320. So these are, you can, okay, let me setting a bit the region and checking what is going on, okay? And from now on, all my analysis will be used in that way. This is with the graphical user interface. Now you can see how you can do it with a command line, okay? But of course, for example, this one can be useful to see your corner, you know, okay, let me see Norway, how they are this corner, and then you can get this corner and put in the command line for your regional setting. And this is perfect the same when you do over here, G region, look, the G region now has been changed. It's 320, rather before it was 441. Okay? So again, now if you do some output, and we will see, it's going to be only for that area. You can go back to the previous region if you do G region minus D. So when you create a location, we will see the G region is your full extent. If you do an action, then you can reduce it. And then if you do the minus D, it's bringing back to the full extent. So in this case, okay, let me test everything with a small study region, and when you are ready, you put the G region minus D, and you extend. So you can change the G region also giving the parameter of north, south, and east, and so on. And you can overwrite, and in the meantime, you can also save it as a file for a later use. Okay? So you can, if you can imagine, you can build up, and now we are going to see this file. So you run in this one, Scandinavia. So let's see where this file is. So if you say ls Europe, I was in g.gis environment, so I was in psem, so psem stat, default wind, let's do like this, find inside here, under permanent windows, I have my file. Okay, so inside here, you will have inside Windows, you will have all your map set. This Scandinavia is what? Is what? It's just a text file. My Scandinavia is just a text file. Now question, can I create this text file with some other software, and rather than create Scandinavia, I can create tiles? Yes. So you can create tiles 1, tiles 2, tiles 3, and then what you can do it? Each single site, the full location you send to the node, and each single site is going to be processed by one CPU. Okay, so in that case, you are in the multi-core process, but require a bit of time. But there is where you can arrive, okay, knowing these tricks. And nothing else, and everything is defined by raster image, vector image, and text file that can be manipulated under other software, command line. You can even open this one with an editor like gedit, and then you go here and you change. You say, okay, rather than this, I want this. You save it, close, save it, close. And now if you print again your map set, it was G region minus P. Now you have the number modified by another software, okay? So these are just text files that you can use it. So we saw the G region setting that can be done by graphical user interface in that way, by zooming. I didn't use so much this one. I just use it for didactic. Extend from display. So if you do in display, it's going to take the full region. If you zoom in this area and then you do setting from display, now your G region is going to be so big. So if you go back over here and you reprint, you can see that the row now has been changed, okay? Row 2000, you are 1000 and more. So you can play as you want with the G region. Okay, so let's see an example. So I set up the region in that way, and I want to do a calculation. So I want to take a file, glist rust, sorry, glist minus p. Okay, so I want to take, let's take these FNFPC. You can take, again, you can take any one. So now you do, for example, R map calc that allow you to make a calculation. And you say, okay, create my crop equal to FNFPC, my original one, times, I don't know, 2 to the power of 2, whatever. So now, as you can see, that the computation has been quite fast. My region is very small. Now, if I plot my new map, that is going to be in my, where I was in psem stat crop, apply, okay, so now my map is smaller, okay, so I process only for that area. And of course, from there, you can, adding more command, is going to be output only for this, and then before, to expand it, you do minus D. Let's try. G region minus D. I think the minus D is already the full extent. And now if you reprocess, you have to overwrite. Yeah, look, now it's computing, it's already going not so fast. Look how it's, how slowly it's going, because it's bigger, okay? So, and of course, when you want to test it, you cannot wait all this time. Perfect. So you can bring it back to Scandinavia. I think you need to put the command there. G region minus P name raster. You can set up the G region based also to other vector file. In my case, it is a text file, so region equal. So I can do region equal how it was the name. So now I bring him back to the original output, and now that I want to run, so now it's going faster because it's smaller. Okay, so this is how you play with these tools. Okay, I think we cover quite yeah, this resolution cropping, this is what I just mentioned now with the different. Something that you also can change is the resolution of your pixel. So you can setting region Scandinavia, you can setting the, when we did the full line with the north and south, you can also adding, so when you adding this one, you can also now adding the resolution. Is one, or resolution equal to 20,000, okay? So what does it mean? You're setting up the resolution for the output, not for your input. So now, res, it's not res, res equal value, because so now you can set in the resolution. Now if you rerun the computation, is even faster, is already over, and if you refresh, you have the resolution changed. Okay, so again you can keep smaller but also change the resolution. Your underline, these are just the output, your underline map is still the same, didn't change, is whatever the output is, the output. It's just a faster resampling technique to allow you to see what is going on. Okay, so you can change the resolution. Yeah, these are example, I just made it. Okay, and the visualization we already did it. Okay, you want to have a bit of time, like before 2, 3, 4, 5 minutes to play a bit, change the resolution, and try run a RMap calc, and you can see over here the command. You can try setting different region, make an output, and then see the difference and so on.
So are there any differences to using the grass layer manager versus QGIS? Do you have a preference? Or?
Just for the display?
Just for display.
I think for QGIS is missing a plugin that allow you to import the data, or at least it's not in this version. I have to check better.
Okay. Yeah, that wasn't working for me with the grass plugin.
Yes, I think I have to read in some forum. I was reading before, and it seems that it is not yet available for this QGIS version, so it's available for the previous one.
Oh, okay.
But in the end, I use the graphical user interface of GRASS,
Okay.
just for fast visualization. And then when you get familiar in your processing, is you can output a TIFF, and then the TIFF you can open with any software, you know. So I just do it in this way, and every time that I close, I just put the output as a TIFF, and then I open with OpenEV or some others. Yeah. Okay. Okay. So just wrap up this section. So we saw g.gis environment env to see where are you under environment under grass. We see g.list for listing raster. We saw also how to change the different map set with the G map set add or switching. And then from there you can adding the different, these are the most, the black box of grass. And then from here you can keep adding the different scripting line and procedure one behind the other. They're quite straightforward. And then of course you can search for how to make a buffer, how to make our neighborhood and so on. But these are the key part that is very important to understand. So this was again for doing something that already exists. So now we are going to the option, okay, now I go home, I have my TIFF, my shapefile, I want to start a grass location. And when you start it, then you are going to follow all this procedure to do it. But let's see one step before how we can do it. So, so exit completely. So you can write exit. So please be sure that you exit. So you are back in your bash directory. Just so at this point, now should start. Okay, so at this point you just enter grass72 Vuix Python. Okay, so this is the graphical user interface that you can use to enter by a location. You select your location, you navigate, if you is not appearing, navigate over here and you can select. So for doing this, let's create first a directory. So you can see, or you close this one and we create first a directory. I think it's easier. So if you just create a directory, so you do make dir ost for SAM grassdb new. So this is something completely new that you are going to create. And you can put the option -r, in this way is going to overwriting invalid option. Sorry. I think you don't have this directory, make dir grass database new. Yeah, just create a completely empty directory. So now that you create a directory completely empty, you open your grass, you migrate in the completely empty directory. So user ost for SAM grass database new. Okay, so now you have the complaint of grass. There is no location, there is no map set. So now you are going to do new location, okay? You write up your name, the name of the location. You can put, for example, Europe 2. Now the best option, you just click next, is to use a file that already have the reference system. So now if you do projection, this one, so read projection and datum from a file system. So now if you do like this, it's going to ask, okay, which file you want to do it. So you go into your directory and you pick up the one that you want to use it to build up your so in this case you can grass database, sorry, in the exercise there are some files. You can pick up any file, gdal.ogr, and you can pick up this one, for example, input proj.tif. So you go ost for SAM exercise basic and input proj.tif, and over there you are ready to click and to have everything ready to go. He's asking if you want imported, you say yes. Okay, successfully imported, and now you are under GRASS database new, Europe 2 is creating it automatically the permanent, and inside to the permanent is going to be this file that has been created. And this, you can see, so now it's starting all the GRASS, but you did nothing else that over here you create this one, Europe 2, permanent, and inside all these structure that I said before. So this is how you do it with a graphical user interface. You can do it with a TIFF, or you can do it also with a shapefile. It's the same. Okay, so first thing to do it, empty folder. Actually, I also insert in the empty folder the TIFF that I want to use it. This way I remember that that location has been created with that field, with that file, with that projection and everything. Okay? And you build up everything. Okay, I think it's quite straightforward. You are following without problem. Any question about this procedure? Now that I think now that you have in mind the 3-step is coming easier, no? Isn't it? Okay, so let's see the other exercise with the graphical user interface, sorry, with the command line. So if you go again back to the GRASS over here, and you scrolling down, you do this one, create location using ancillary layer with a command line, the first one. Okay, now you will see that it's even easier with the command line, okay? So, and probably we can comment even together, and then we can run. So the first one, bash people. Come on, you know, first one. Remove the folder, perfect. Then make a new one completely empty. Then copy this file to the directory, okay? Just copy. Then people in the first workshop. Okay? Define the projection. Be sure that this file is with the 4326, because we mentioned that, and we mentioned, I repeat, try always to build up a location with a file that has the right projection. You are 100% sure that is the right projection and has all the parameters already filled up. In this way, you can be sure that if you assign an APSG code, that in this case the 4326 is the VGS84 that Google and mobiles and everybody's using, okay? So now that you are here, you can use this file to, you are sure, okay, just remove the new location, and then you do the use GRASS72 in text mode using this file, name of the location, and then location path of the GRASS database. That's it. Very easy. And it's building up everything. Okay? So we can try step by step. You can also go for it. You can copy even more line. Okay, now I copy. I make the digital warp to be sure that my projection is correct. How I can see? How can see if I have projection? How I can see if I have projection? GDAL. GDAL. Come on, Brian. I'm waiting for you.
Oh, sorry.
GDAL info. Okay. Now you can have a projection. You have APSG 24. You can see that is good file. And now you can run this line to build up the grass, okay? He's entering in automatically in grass, but is empty. There is nothing. G.list, Rust, completely empty. So he's building up only the folder. And actually, if you see, there is also not completely built up. So we are in OST for SAM, Grata database new. Look, you have the new location, the permanent. Inside the permanent, you don't have yet all the folder. So now at this point, you import the data. So in this, you can do it with the RNG input, RNGDAL, that you can import. This is the command to import it inside grass. So now, ingested, glist, you have your file, input proj, and now all the different cells, LH, cell, has been created. Okay, it's not difficult. If you find these 4 lines, you build up your location without struggling, okay? But again, pay attention that the file has to be with the right projection, okay?
Is there any way to transform?
What do you mean transform?
Transform the projection to another?
Yes, so if you want to, over here, you want to, this is target, source. Here you put another number. Now I don't know, I have to look it. But you put another number, it's going to be 4220, change it, and then you import it. Yeah, this is define the projection. You are just giving the right number. You are not changing the projection system, yeah. But of course, yes, there are, if you're changing, yeah. So any question, this direction? I have one question for you. You will be able to build up a location with your data now? If you go home? Okay, if you do in 1 month, no. But if you do tomorrow, I think you would, this is the aim, no? If you are able to build up a location and map set straightforward, and then you proceed slowly and build up your scripting procedure, but this is the way, okay? So try to use as much as possible these tools. In the beginning, the learning phase is quite slowly, but then all the time you are going to receive back because you'll be more efficient, faster, and then everything, okay? Yeah. You can build up a scripting procedure to import all the file with a for loop, for file in all the TIFF, use RNGDAL, done. It's going to import all the TIFF that you have in the directory, okay? Be careful, this one, just to let you know, there is RNGDAL is importing the data, so you will have a data duplication. You will have your TIFF, and then inside of the location map set, you will have the same file, so double. So if you go in the massive data process, having 2 terabyte replicate is not really convenient. So there is a command that is r.external, that is just create a link. It's not importing the TIFF, it just create a link. So it's something that you can use afterwards, keep in mind. Not for now, but keep in mind, yeah? So was for the GRASS workshop. So if you have question in this contest or free chat in how we can use it, do you think we can be done this, and how we can spend a few minutes for your question.
Files to a location or a space. Use just one line.
Sorry, can we import?
Import like multiple files at the same time.
Yeah. So this for loop. This for loop for file in all the TIFF. Importing with using RGDAL, done. It's going to import all of them. Yeah. So all the for loop, you can use it by importing. You can use it under here. Importing, create a buffer, and exporting, for example. Or can be this for loop can be even longer. Okay.
Once we have that, the projection of the file. I mean, can we like display the map in another different projection?
So GRASS is very tight with the projection. So I always suggest to working in one specific projection in GRASS, do all the computation, and then if you need, you export it, you change it with digital warp, and then you visualize. Okay? So because the projection in GRASS, you can create also different location with different projection. I'm working more at global level, so I always work with WGS84. So I don't dealing so much with the projection, but if I have it, I prepare my data before to enter in GRASS. And when I am in GRASS, I'm sure that everything is under the same projection system, because he's very picky. He's going to complain a lot. Yeah. Okay. Okay. So this was for today. So next workshop is going to be on the application of hydrological modeling using GRASS. Okay. There are plenty of modules in GRASS. I mean, we just saw how to start it, but there are really many, and you can do all the different kind of computation. You can do it. If you want to get the histogram of an image, you want to do supervised classification, you want to do unmixing analysis in image, in many watershed analysis for hydrological modeling, correlation between two raster, huge correlation between two raster. You can do it. They are starting to do it also. There are modules for do machine learning for image analysis, and over there is going more and more. So this is the capability that you can have under your fingers. And next workshop is going to be for hydrological modeling. Even if you are not dealing with hydrological model, I would suggest to come, because you get a feeling of what you can do it in general. And then you can apply to your vegetation map or to your animal pattern. Okay, so this is the... and then, in particular, I'm going to point to this. In May, we are going to have this 1 week training over here, and we are going to cover this. Of course, I'm going to start the GRASS again from scratch, but there are going to be modules from we're learning for R, Python in the geographical domain, language integration. So that one is going to be quite appealing to follow up, because you can leveraging even more. Don't think that it's going to be 1 week, because this week is coming back to you. Because if you are going to do it the same starting location and everything, it will take 2-3 days for you to do it. Now you go home, 10 minutes, done. Okay, so it's really, you gain time if you follow a procedure and you have material where you can do it again. Okay, so spread the news also for this one. I'm going to stick all these leaflet around campus, but if you want more, are here and you can paste in your department and so on. And that's it. Yeah, keep working under. I'm running office hours every Wednesday and Friday over here. So feel free to come. Wednesday in the library and Friday over here. Feel free to come and discussing project and yeah. Welcome.